If you want to build an FPV drone or an airplane, you just have to have a flight controller. Okay, maybe in case of the airplane it's not really strictly required, but having one makes your life much easier. This video will tell you everything you have to know about the flight controller hardware, but also a few bits of information about the flight controller software. Let's go! The most basic question is what a flight controller does. One might say that it's controlling a flight. But don't you think that this is too recursive on the answer and the truth lies somewhere else? The flight controller provides two basic functionalities. The first of them is the ability to decode the RC signal, the information that comes from your RC radio. We have different radios and different receivers, and the flight controller has to be able to understand them all. On top of that, the flight controller provides the stabilization. It adds a PID controllers and is able to drive the motors and servos so that your UAV, either this is a multirotor drone or the airplane, is stable in flight. Yes, of course, airplanes are inherently stable in flight, but correctly chosen and configured flight controller can make the whole experience much smoother. And in case of FPV drones, you just have to have the stabilization. The drones do not fly without the stabilization, or rather they fly for an extremely limited amount of time before they crash and even sometimes get destroyed. The next question is what each flight controller has to have. I mean, what kind of the hardware has to be put on this small electronic board so we can call it a flight controller. And there are some elements that are just required while some are purely optional. First of all, we have to have a brain. This means each flight controller has own microcontroller, usually from the STM32 family, that is just a computer that provides all the functions that flight controller has to do. Stabilization, navigation, ports, landing, arming, configuration. Everything is performed by the small computer located on this board. Next, we have to have the gyroscope and the accelerometer. Both of those sensors are used to be able to track the orientation of your craft in the air. Gyro provides the angular velocity, while the accelerometer measures the acceleration, and thanks to that the flight controller knows where the ground is. Thanks to the gyro and the accelerometer, the flight controller is able to measure how fast it is rotating on roll, pitch and yaw axis, as well as it knows the inclination angle, how much it's tilted either to the left, right, front or back. And those two sensors are essential for the flight controller to provide the stabilization. In all the modern flight controllers, both of those sensors, gyro and the accelerometer, are actually one chipset. The next required elements are the inputs and outputs. Inputs, usually in form of the serial ports and the I2C bus, are just used to connect external elements and sensors to your flight controller. The external elements would be radio receiver, GPS module, magnetometer, digital FPV, analog FPV, you name it. And of course, outputs are used to connect motors and servos. The multirotor drones achieve the stability thanks to very precise driving of the rotation speed of each of the motors, while the airplanes do the same thanks to the servos and the control surfaces that they drive. And finally, the last required element is the voltage stabilization. Currently, we like to power our airplanes and drones from the relatively high voltage, 14, 16, maybe even 20 something volts, while the whole electronics run on 5, 3.3 volts and even less. This is why a flight controller has to be able to step down the input voltage into the voltage all the components and accessories are able to utilize. And the quality and the maximum allowed load on the voltage stabilization decides on how stable your flight will be, and how much of the components you will be able to connect. And then there is the whole plethora of the optional components, and those would be the analog OSD chipset. Thanks to this chipset, the flight controller has the possibility to overlay the OSD on the signal from your camera that is then transmitted to your goggles. Of course, it's not strictly required, especially when you are not using the analog FPV at all, but considering the price and the fact that, well, you might just want to use a flight controller with the analog FPV, even if though you are flying mostly digital, it's a good idea to have it on board. Right after the digital FPV appeared on the market, some of the manufacturers try to cut the cost and do not put the OSD chipset on their flight controllers, but now on the majority of the flight controllers they are back. Turns out it's not really that much economically viable to have two versions of the same flight controllers. Pilots get confused, customer service gets contacted, it's just not worth it. And then there are features like I2C bus used to connect some sensors, for example magnetometers that are required for the precise navigation, barometer, voltage and current sensors, Bluetooth for the wireless configurations, and all the other sensors and peripherals the manufacturers and the authors of the flight controller software might think it's worth to have. Now, what are the types of the flight controllers? There are two major types of the flight controllers. One is the multirotor oriented and the second one is the airplane oriented. This is just a specialization of the flight controller. It doesn't mean that you cannot use a multirotor flight controller on the airplane or the airplane flight controller on the multirotor drone, but most probably you will face some challenges that would be non-existent if you just chosen the correct hardware in the first place. Then the multirotor flight controllers can be divided into two subcategories: the general purpose flight controllers and all-in-ones. All-in-ones, just like the name suggests, have everything in one. Especially they usually have a built-in ESCs. With the all-in-ones you just don't need separate ESCs or the 4-in-1 ESC to connect to the brushless motors. Everything is integrated on the one small board. When talking about the airplane flight controllers, there are two main features that distinguish them from the multirotor ones. First of all, they have the integrated PDB, a power distribution board to connect separate ESCs to drive the motors on the airplane. And on top of that, they have a dedicated servo rail with a strong voltage stabilization used only by the servos. Servos, even small servos, when stalled, can pull quite a lot of current. And if you try to connect a servo or servos directly to the multirotor's flight controller voltage stabilization, well, the things might release the magic smoke. Airplane-specific flight controller just have beefy voltage stabilization, 3, maybe even more amps on the 5 volts only to power the servos. And of course, because there is no strict form factor limitations in the airplanes, they can have totally different shapes and sizes. Sky is the limit. As we are on the topic of the flight controller form factor, there is not a standard form factor for airplane flight controllers. So when getting one for your first or next airplane, the only thing you really have to check is, will it fit inside your model? In case of the multirotor flight controllers, there are currently 3 most popular form factors, and they are described by the distance between the mounting holes and the orientation of the flight controller. The big standard flight controllers are the one with the 30.5 by 30.5 millimeter hole spacing. The mini flight controllers have 20 by 20 millimeter hole spacing, while the 25 by 25 millimeters, usually rotated 45 degrees, are usually reserved for the all-in-one for the twig-style drones. Yes, of course, there are drone frames that can fit both 30 by 30 and 20 by 20, but usually when you have a frame designed for the 25 by 25 45 degrees rotated, this is the only flight controller you will fit. Not always, but usually, so pay attention. And then we come to the aspect of the software. So far we discussed only a hardware, but like every computer, the hardware can do squat before a software. This is why your flight controller hardware will need a flight controller software. Currently there are three the most popular flight controller softwares: Ardupilot, Betaflight and INAV. We will not go into differences between them because I have a special video about this topic, but for now let me just say that Ardupilot is usually for the full-blown navigation, Betaflight is for only racing and freestyle, while INAV is somewhere in between. It can both do freestyle racing as well as very good, very nice and very precise GPS navigation. Jack of all trades, you might say. And the funny thing is that usually the hardware is compatible with all three of them. In most of the cases, if the flight controller works with INAV, it also works with Ardupilot and Betaflight. If it works with Betaflight, then usually it also works with INAV and might work with Ardupilot. There are, however, microcontrollers that are not compatible with the Ardupilot at all. Those are F411s and F722s. Those two MCU families will run only Betaflight and INAV. Plus, there is also a family of the flight controllers that is compatible only with the Ardupilot, and usually you will have very limited chances of running those with Betaflight or INAV. And if the hardwares are compatible, you can swap the softwares on your flight controller as you wish. You have the freedom and you can decide which software you want to run. You only have to remember about the checking if the hardware is really supported by the software you want to use, and make a backup of your settings so you can just go back. And the same goes for the upgrading the version of the firmware you are actually using. If you are on the Betaflight 4.2, you might just upgrade to 4.4 and everything will be just fine. But always make backup and note from which version you are coming, so you can just go back whenever you want. And no, you cannot brick the flight controller, at least if this is the STM32 flight controller. The bootloader on the STM32 flight controller is located in the read-only memory. You cannot just override it. It will be always there, and that means that you can always flash. Let's talk about gyros. The gyro is the essential sensor. You cannot have a flight controller without a good gyro. And there are different gyros put on the flight controllers. Different manufacturers, different models, different characteristics. And yes, there will be a difference of how the flight controller with, for example, MPU 6000 versus the BMI 270 behaves in the air. But as long as there are no problems and the bugs in the drivers, all of them should be flyable. And if you are not a top-notch professional pilot, most probably you will not notice any difference. Luckily, the days when you had to do some magical mambo-jumbo depending on which gyro your flight controller had are long gone. We have advanced and very good systems on the filtering. That means the practical differences, although still there, are not that big of a deal. So yeah, if you're just a beginner pilot, don't spend too much on choosing the correct gyro for your build. You will spend quite a lot of time and effort to choose something that you will not really be able to appreciate. And by the way, MPU 6000 is still the best gyro out there, but everything else works too. And finally, I have some tips for you when choosing your first or second or third or end flight controller. 1. You will need serial ports, and with modern FPV systems and radio receivers, you will need at least 3 hardware serial ports. Not 2 hardware and 1 software serial. Let's just forget about software serials completely. They are currently rather useless things. You just have to have at least 3 hardware serial ports, period. 1 for the radio receiver, 1 for digital FPV, and the third one for either GPS or the ESC telemetry, or Bluetooth, or Wi-Fi, or anything else. I2C pads are advised, not strictly required, but if one day you will want to connect, for example, a magnetometer or external barometer, you will just have to have I2C ports broken out. Every STM32 microcontroller has the I2C port, but not every manufacturer decides to put a pads on your flight controller when you can just solder the wires. So pay attention and rather choose a flight controller that has the I2C broken out. Which version of the STM32 flight controller should you buy? Well, let's say like that. Do not buy F411s and rather do not buy F722s. My personal advice is to go with F405, eventually with the F745s, and if you want the best of the best of the biggest and the best, then go with the H7. But F411 and F722, although they are the cheapest, do not buy them. You might wake up in the situation when in the year or two there will be no software you can use with them anymore. Onboard baro? Yes. Because why not? And how many outputs the flight controller should have depends on what you want to do with your flight controller. If you only want to use it on the quadcopter, then of course 4 motor outputs will be all that you need. But for example, if you want to build an octacopter with 8 motors, then well, you have to have a flight controller that supports 8 motors. And the fact that it has 8 outputs doesn't mean that it supports 8 motors. Always check the specification of the hardware you want to buy. And a very similar situation is with the airplanes. Because the function of the output cannot really be freely assigned, then the number of the outputs does not really mean that the number of the motors and servos you can connect to it is the same. All the motor and servo outputs are grouped with timers, and one timer can have only one function. If outputs 1 to 4 are connected internally to the same timer, that means the outputs from 1 to 4 all have to have the same function, either motor or servo. Here's the next video you should watch. In the meantime, this was the FPV University. I'm Paweł Spychalski. Thank you very much for watching and, like always, happy flying!